Molecular pharmacology group that I established here at the University of Geneva is mainly interested on identification of effective drug combinations for cancer treatment. And to do that, we develop different methods and platforms, not only to find such combinations, but also to validate their activity. Our laboratory developed in vitro three-dimensional co-culture models to screen different treatments, to bring the answer, yes or no, the treatment is effective, closer to the real conditions, which are in vivo conditions. So, of course, everything that is in vitro or ex vivo is away from the organism. So the whole organization that makes an organ alive. So we have to consider that and remember that choosing our model for our research. For instance, in cancer research, very often in older times, people used cancer cells that were seated in a flat 2D dimension, and they were exposing those to different treatments and made estimations that this type of treatment would be effective, and then went to eventual tests in vivo. Now we know already that this type of models is not very efficient, neither real, in fact, because in reality tumors are actually three-dimensional, and they are not only composed of cancer cells, but also tumor microenvironment that also makes a huge difference in the activity of the drugs. So all this is linked together. There is a crosstalk between those different types of cells. There is vasculature that brings nutrition and oxygenation. So all this machinery needs to be together to mimic something that is then present also in vivo. So the challenge is to make that all components together somehow working and giving this interaction to try to translate to the in vivo conditions. I think there are things that we can still improve, obviously, but I wanted to mention two of them. So first of all is the vascularization. So to make in a in vitro spheres vascularization that is actually working, so providing the flow and oxygen is much more difficult than in what we're doing now. And of course it takes more time, and you need to probably use fluidic system to actually deliver the flow and so on. So this is next step that we will work on. And importantly, the second issue is information on immune response that would be an added value to the activity of our treatment. Now in vitro systems it's very difficult to mimic that because of the complexity of the immune system per se. So we can try to add to our co-cultures T cells or macrophages or different parts of this immune system, but the fact that one of those, one or two or three, would respond, it doesn't mean that full system would do the same. So in order to see if the whole organs or the whole system would work together, we have to go to in vivo model to have a full answer.